Alright, so here's video 4, a quick review of parent functions and how to shift them. It will be fast. So what I have on the screen right now is just y equals x. We can shift that up, down, left, right, stretch, pull, twist. We're more often than not used to y equals mx plus b for the y-intercept form. Then we have our power function, y equals x squared, a parabola. The next power function we want to know, and that's an even function, is y equals x cubed, and that's going to be an odd function. It's shown there in green, and again that means it's symmetrical about the origin. This portion and this portion are symmetrical, whereas in the previous one it was symmetrical across the y-axis. The next one, y equals square root of x, has a domain of 0 to infinity. It can only be a positive number, whereas if I go to the cube root of x, an odd number for an index, has a domain of all reals, and it's shown there. We have the reciprocal function 1 over x, which is a rational function, a polynomial top and bottom. And then I jump into some trig functions here before I do some other things. I have y equals sine x. Again, it goes through the origin, versus cosine, which starts at positive 1 when there's x radians, or 0 radians. Again, tangent is sine over cosine, and so anytime that the cosine function is 0, like right here, or right here, you know that tangent will have asymptotes. So if I remove those, you can see that the tangent curve has vertical asymptotes at pi over 2 and 3 pi over 2. To show secant, I like to, and this is the only reciprocal function I have, we just recognize that reciprocal functions, secant and cosecant, are going to bounce off their respective trig function. I think a function that helps a lot, instead of witnessing number 11 here as a composite, the way it would help is if we graph it, we recognize that as a semicircle, and since it's positive out front, it's positive above. I change this to a negative, it just goes to the bottom. And then our exponential functions, y equals a to the x. Here's 3 to the x. If I make that 0.3, it goes the other way, but 3 to the x is this way. Its inverse is is the log function, shown here in red, which mirrors across y equals x. But often we use e, which if I put on here is just 2.71, but it's an irrational number. And y equals ln x is its inverse. Again, these are our parent functions. A quick discussion on shifting can be shown here. So if we start with y equals x squared, an even function. The one thing we know about an even function is if we shift it up or down. If I add 2, and I show that graphed, boom, that moves it up 2. If I want to go down 3, I can shift it down 3. If, when I bring it back, I want to go to the right, I can't add 2, I have to subtract 2. And I explain to students all the time, what makes this 0? Positive 2 makes x minus 2 0. And you think about it, when we plug 0 into our original function, 0, 0 is a point. When we plug 2 into this portion, we get 0, so it's 2 to the right. If I want to shift left, I have to add 2. Now stretching and pulling and twisting. Right now they're laying on top of each other. What happens with a 2? Well, a 2 is going to stretch it vertically. I always talk about grabbing this point right here and pulling it up. It's like you pull it in a taffy puller. If I put the multiplier here, it's going to look somewhat similar, but I want to be that we're pressing this point in when the multiplier is on the inside. So again, shifting functions takes quite a bit of practice. If you remember it from pre-calc, you just keep practicing. The last thing I want to show you is a piecewise function. So here's a piecewise function. It's a line to x negative 2 and a parabola here. And I put it in another function so I could put it right over top, make red and black. So what happens when I put the multiplier in on this one? You can see that I've steepened the slope of the line and I've stretched it vertically. And again, that multiplier is on the outside, so it's the result. Whereas if I put it on the inside on these values, I compress it in the x direction. Again, keep practicing. There are other videos that are longer. This is just a quick review video.